Hello there, chemistry students. This is a commentary of an exam question on atomic structure. Please feel free to pause the video at certain points and ask questions in the chat if anything's unclear. It's an A-level chemistry question, and we're going to look particularly at electron configuration, ionisation energy, relative atomic mass, and mass spectroscopy. I'll let you have a look at this and you can pause the question now. Welcome back. So we've got the electron configuration of two ions to think about, and with the Cl- ion that means one extra electron based on the proton number, and with the Fe2+ ion it means we've got two fewer electrons because of the 2+ charge. You could have any number of different atoms or ions where you have to give the electron configuration. No matter what you do, you have to memorize the order of filling of the shells. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Without knowing that order, you can't begin the question. You fill the lowest energy subshell first of all. Fill subshells singly until they have to be spin paired. Copper and chromium are exceptions to this, but we haven't got copper and chromium here. So 1s2, 2s2, 2p6, 3s2, 3p6 for the chloride ion, so that makes a total of 18 electrons. With the Fe2+, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Now, what's happened to the 4s? We have to remember a couple of special rules. As we said, with the copper and the chromium, but also when we're dealing with ions. 4s electrons are always lost first when forming ions. I did mention earlier that copper and chromium are exceptions, not relevant to this question, but while we're here, we should remember them. If we can fill the 3d shell evenly, as in the case of copper and chromium, 4s1 3d5 or 4s1 3d10, that means that we don't fill the 4s first of all. We just singly fill the 4s and then the 3d5. I'll let you have a little look at this question now. Please feel free to pause it. Welcome back. So an equation with state symbols to represent the third ionisation energy. You could be asked in words, you could be asked in an equation, and you have to be able to link the equation to the words. So third ionisation energy is the energy required to remove 1 mole of electrons from 1 mole of 2+ ions to create 1 mole of 3+ ions in the gaseous state. The gaseous state is essential. So there we've got our 2+ ions going to 3+ ions, and we can see that the electrons are being removed. Now for only 1 mark, that is not worth the point at the moment, so that's not worth the mark at the moment. State symbols are absolutely essential. Okay, next question, or next part of this question, feel free to pause the video now. Welcome back. So you have to know the main reasons to explain ionisation energy, and so that will be about the distance between the outer shell electron and the nucleus, the shielding effect from full inner shells, and the size of the nuclear charge, and all those three factors combine to impact what we call the nuclear attraction. There's also exceptions, and this one's an exception. So it's worthwhile noting the exceptions, and so there's magnesium and aluminium that we're looking at here. Magnesium and aluminium, we can get a clearer view of what's going on by giving the full electron configuration in box notation. So in terms of our box notation, we can fill the magnesium from knowing the proton number, and we can see that the outermost electron is spin paired in a 3s subshell. Aluminium, on the other hand, has got a unpaired electron in a 3p subshell. So aluminium has got the lowest first ionisation energy. The reason for this is because the outermost electron of aluminium is in a 3p subshell, and this is higher in energy than the 3s electron in the magnesium, and therefore easier to remove. Okay, a bit of a lengthy question this one. Feel free to pause the video. Welcome back. So we've got a mass spectroscopy question. We've got some data to calculate the relative atomic mass of nickel, and we also have to give the formula for the ion, or the symbol for the ion, which is responsible for giving this the detector first of all, for each detector first of all. So the ion is going to reach the detector first of all, is going to be the one with the lowest mass, and so the m over z value, the mass divided by charge, we can assume that all of them have got a charge of 1 or plus 1. So the nickel 58 isotope has got the lowest mass and therefore will reach the detector first of all. So it's going to be nickel 58, but remember it's asking for the symbol of the ion, so it's essential that you put in the plus charge for the nickel 58. So there's the symbol of the ion. To work out the relative atomic mass, we have to get the average mass of the atom, and so we have to use this equation. So 58 times by the percentage of the isotope 58, 60 times by the percentage of the isotope 60, and 61 multiplied by the percentage of the isotope 61, multiplied by the percentage of that. That would give us the mass of 100 atoms, and so the average mass of one atom we simply divide by 100. It did stipulate in the question that you must give your answer to one decimal place, so any other answer apart from 58.9 would be incorrect. Okay, units would be, that's how many grams there are per mole. I think that's the end of this video. I hope I've made sense. If not, please feel free to ask further questions in the comments. Thank you very much.